Now going over to question 16, here we have an important thing that you should be noticing on the SAT, which is the idea of fake inequalities. If you realize that some of the inequalities on this question are fake, what could be one of the toughest questions ever ends up not as bad. So some of the inequalities we're seeing that we're going to kind of discount here are that there are a minimum of 200 candles. We have the maximum number of candles, and we want to stay within the budget. Those are all things that you could very easily consider to be less than and greater than statements. But the logic goes like this. If we consider those to be inequalities, that would be just way too challenging. So let's go ahead and try to just pretend like they're not, like they're just regular equal signs and see what happens. If we don't get to a good answer, then maybe we'll take it to the next level and really think about the inequalities. But here you will actually get to an answer. So let's just go ahead and read this to ourselves, and we'll see that there are $2,200 altogether. The total number of candles is 200. We have the price of small candles of each small candle and the price of each large candle. So really, this is a classic system of linear equations. X can be the number of small candles. Y can be the number of large candles. If that's the case, then X plus Y is going to be 200, the whole number of candles. And the whole amount of money, well, those are your price times quantity statements, which are really common. That's 4.9 times X, so that's the price of a small candle, times the number of small candles, plus 1160 Y. So the price of a large candle times the number of large candles. Now, whenever our X's and our Y's and our numbers all line up like this, that's where you should be thinking about the elimination method, about trying to make things eliminate so that we can solve for our variable. Now, what we're looking for here, what we really need here, is the number of large candles, which is Y. So it makes sense to eliminate X. If you eliminate Y, you'd have to kind of plug your answer back in later to get what we need. So let's just go ahead and start on the right foot. Let's eliminate X. So to do that, you have to kind of realize that there's 4.9x right here. So it would be awful nice to have negative 4.9x. So let's multiply this entire equation by negative 4.9. Negative 4.9x minus 4.9y is equal to negative 980. Make that a little prettier. And now, when we add straight down, 4.9x minus 4.9x, that deleted on me, 4.9x minus 4.9x cancels away. 11.6 minus 4.9, let's do that on the calculator. That's 6.7 y, and 2200 minus 980 is 1220. Now we can divide both sides by 6.7, and we'll get y equals 182.09. Just randomly rounding to the nearest hundredth there. But what is the maximum number of large candles that the owner can purchase to stay within the budget? Well, truly, if the owner purchased 182.09 candles, it would be right on the border. So to stay under the budget, we'll purchase 182 candles, and that'll be our answer for number 16.